Hello, my name is Aaron Balke, and in today's presentation, I'm going to be breaking down my Advanced Data Acquisition Assessment for my Master's of Data Analysis. This assessment really sits on using Postgres in order to run some calculations and all, but it does also have a Tableau presentation involved in it. So that's sort of the setup to this project and assessment. It may have some assessment specific information in there. Just be aware of that as you're watching it. But I hope you enjoy. Hello, my name is Aaron Balke, and today I'm going to be breaking down my D211 Advanced Data Acquisition Performance Assessment. For this performance assessment, we are using PG Admin 4 version 5.2, Tableau Professional Edition 2021, and a Windows 11 virtual environment. And we're going to show off some of our dashboards here, and then we'll explain the process behind the database querying in order to arrive at these dashboards. So, this is similar to my D210 performance assessment, where I wanted to compare two different hospital systems, and in our situation it was our WGU one versus a hypothetical DIA one. The DIA dataset came from the National Kidney and Diabetes group, and they provided this data set in order to help with predicting if someone has diabetes or not, but it provides us with age, gender, high blood pressure, overweight, and diabetes features that we're able to use in order to use it as another hospital system and perform comparison analytics between our WGU and, in our situation, our DIA hospital system as the other data set. The first page here, the first dashboard here, is just going over some basic comparisons. So we have the WGU gender breakdown: 50% women, almost 48% men, and 2% prefer not to answer or non-binary. The DIA data set is 100% female. That is one big difference between our two data sets, and something we have to keep in mind moving forward. The other thing that we can tell from the overweight and high blood pressure data is that the DIA data set has a massive decrease in the amount of older patients. So as we look at the overweight section, for example, we can see they have close to 10, 20 times more 20-year-olds than they do 80-year-olds. It gets down to zero there at the end. And so that is the main point I'm trying to make with our analysis here and with our dashboards, is I want to show how, yes, they have more healthy 20-year-olds and all, but we have a much more consistent population of patients. We have patients that are living much longer through many age-related illnesses and all. They're getting older and they're still healthy, because we still have a ton of people coming in the door who are 70, 80, and 90. We can see from here the overweight stuff. We're able to see that our patients are overweight more often than not when compared to the DIA data set. So we can see here it's very steady, more overweight than not overweight. This is not the case with the DIA data set. We can see that they have a more young people who are not overweight, but when we get down to older folks, they're sitting about equal. So about equal when it comes to overweight. When we check out the high blood pressure metric, we can see we're about the same amount of not high blood pressure and those with high blood pressure when it comes to our population. It's about 50-50 for all ages. And then when it comes to the DIA data set, they do have more young people with low blood pressure or not high blood pressure, but as you get older, it becomes even similar to ours. So that was the main point of this dashboard here. I wanted to paint that, yes, they do have a healthier, younger population. However, they don't have as many older folks coming in their doors. And so something we have a very good metric is just having older patients. And along those lines, when we check out the extreme KPIs, I want to take the extremes. So which populations are, or which portion of our population is all healthy metrics. So which of our population has not high blood pressure, isn't diabetic, is not overweight. And then also the all unhealthy indicators, which of our population, or which portion of our population is diabetic, is overweight, and does have high blood pressure. And so I wanted to compare those two extreme groups between our data sets in order to see how those distributions across ages work, following the same line of thinking as our previous dashboard. And as we can see, we got the WGU all healthy metrics here and the DIA all healthy metrics. And so as you can see, we're very consistent when it comes to ages. We have pretty much the same exact amount of young patients who are all healthy metrics as our older population, which is all healthy metrics. Now, this is not the case with the DIA hospital system. They start with a ton of all healthy metrics and patients. However, by the time you hit 30, their patients are not all hitting all healthy indicators. They are getting mixed up. Some are becoming overweight, some are becoming diabetic, some are becoming high blood pressure patients. And so they have nowhere near the same amount of all healthy indicators as we do relative to populations and all. When it comes to unhealthy indicators, we're staying steady as well. We're keeping the same amount of patients with all unhealthy indicators, so you don't see a massive increase in unhealthy indicators as people get older. And the DIA unhealthy indicators is similar, where they're sitting at about the same amount of unhealthy indicators across ages, which sounds good, but when you take into account that they're also dropping a massive amount of healthy indicators while keeping a steady all unhealthy indicators, it means they're getting a lot of people mixed up in that center group of people that either have high blood pressure, either are overweight, or either are diabetic. So what I really wanted to paint with this demonstration and this presentation is that our data set is consistent across ages. We have the same amount of healthy indicators for 20-year-olds as 80-year-olds. We have a consistent amount of all age groups. We have the same amount of 20-year-olds walking in our door as we do 80-year-olds, which is a really good thing from a hospital system perspective. It means our old patients aren't all dying, So that's the one strength our WGU hospital system has over our competitor DIA. They have a massive decrease in patients as time goes on, and they don't have the same amount of steady, all healthy indicators as we do. So, wanted to explain that there. When it comes to the functionality of these dashboards, on all of the graphs here, all of the plots, if you hover over any data point, it provides explicit information, so the explicit count, the explicit age you're hanging out over. And the reason for that is to help with the colorblind population and to just provide exact amounts. A graph doesn't help that much in showing exact amounts. If you want an exact amount, you can hover over each portion here. And same goes for these graphs on the demographics page and the pie charts at the top of the demographics page. So those are our dashboards. And now we'll show off the SQL. So let me open up Postgres here. The SQL is doing most of the heavy lifting here. And so the first thing we do with the SQL is we want to create a view of the WGU info patient data and only keep the stuff that we want to take into Tableau. And so we have the age, gender, high blood pressure, overweight, and diabetic features here. But then I also have the case statements here are working sort of as if-else statements. And so I want to check if they're overweight, diabetic, and high blood pressure. If they are all of those things, then we have all unhealthy indicators. If they don't have any of those things, then they're all healthy indicators. And so when we run this, it adds a new column and feature to our view, which is if the patients are all healthy or all unhealthy. And that allows us to easily import the new data into Tableau. We're able to do all the heavy lifting in the SQL query. And that is just coming from the patient table and the service add-on table. The service add-on table, I believe it was the high blood pressure, diabetes, and overweight features that had to be connected by patient ID there. So had to do a natural join there in order to get access to those. So that was the first thing I did. I just wanted to get the WGU info in order to create the view. And then we don't have to mess around with the WGU info in the SQL Postgres queries. The next portion is creating the table for the DIA data, the additional data set. And so I created a data set, or I created a table, create a table if not existent, called DIA, and then all of the columns from the additional data set from Kaggle, where we got it, I just have all of those in here. I went through, if it was a integer, I set it as integer. If it was a discrete value, and then if it was a floating point continuous, I set it to numeric. And there we go. And I set the ID to the primary key and not null for all the other values. I figure if there weren't any, but if there were any null values, I didn't want them in the data set. It just would take those out. So that's the creating of the table. We then, if the table exists, which it should be since we just made it, we want to set ourselves to be the owner. Then it's time to import the additional data set itself. And the way I did this was I pulled it from a remote location. I uploaded the data set, I took it from Kaggle, uploaded it to Google Sheets, and then Google Sheets, I'm able to run a curl command and just pull it directly from Google Sheets as long as it's actively being shared. So I decided that would be way easier than making the user or the reviewer of this performance assessment have to move stuff around and import all that good stuff. So I got it copying all of the IDs, the pregnancies, all the other features from that data set, the remote data set that I have stored remotely on Google Sheets. And it's importing it just as a CSV file. There are headers, and it is encoded using UTF-8. So that is the importing of the DIA data itself. Then we have the creation of the view for the DIA data. That way it's nice and filtered and all easy to be imported into Tableau. And so this is very similar to the importing of the WGU data. We have the age, gender, diabetes, overweight, high blood pressure features, and then we have those all healthy if statements where if they're not overweight, not diabetic, and not high blood pressure, then they are all healthy. If they are all yes to those things, then they are all unhealthy. The one complication when it came to this additional data set was that the information was continuous data in the additional data set. So when it came to the instead of being an overweight feature, we had a BMI value. And so we had to use industry standards in order to convert those data, the continuous data, into a yes or no column, a Boolean value. Same thing had to go for blood pressure. And we also had to set all of the gender to female. There wasn't an actual feature for gender, but the data set did say it was all female explicitly. So we had to add that female column, set the gender to female, And then we also, the WGU information is, instead of being like zeros and ones when it came to Boolean and binary features, it was yes or no. And so I decided the easiest thing would be just to convert the additional data set into yes or no's when it came to the binary features. So outcome originally was a 1. Then if outcome, which stands for if they are diabetic or not, we want to set that to yes, and if they're not, we want to set that to no. And then same thing happened with BMI and blood pressure using these case statements, which work like if-else statements. So that is how we create the view for the DIA additional data set. And that is all of the SQL we have to do. So the nice part about this is we don't have to do any sort of functions and calculations on the Tableau side, and that removes, Tableau drives me a little bit crazy. I would much prefer do it all in SQL. So all we have to do is drag and drop these features into Tableau. We don't have to do any fancy calculations there. And that is how the data streams were prepared. All of the preparation was done inside SQL itself. The main stuff that came to the preparation when it came to preparing the data was that converting of Boolean features and also using industry standards to convert continuous variables into Boolean values. And so that's all what happened. It was all with the DIA dataset was most of the work. And the converting of all of that data in the DIA additional dataset allowed us to directly compare the values in the DIA dataset against the data in the WGU dataset. So having the same age columns, we're able to create the dashboards, have two overweight features right next to each other that have the same information. Same thing with the high blood pressure. We're not having BMI values for DIA, something that we're not able to directly compare between the data sets. We have stuff we can compare directly against the data sets now. And the databases themselves, the WGU data was provided by the virtual machine, and the only thing we had to do was add in that additional DIA data set, which was just creating a new table in the current database, the current medical data database, and then importing that data remotely from the Google spreadsheet that was just a copy of the Kaggle data set. When it comes to referential integrity is the concept that when you change data in one place, those changes are reflected in data that has a relationship with that original data. And so in our case, when it came to the WGU data, for example, we had the patient table and the service add-on table. And so when you used a primary key that's shared between those, or a foreign key, such as patient ID, you're able to directly reference the service add-on, one record in the service add-on to a record in the patient table. I will be providing the SQL queries as a document. I will be providing the Tableau dashboards as a document, and some instructions as well for you to set it up yourself. Thank you for watching, and have a good one.